What's going on? Welcome back to the NASA podcast. Today we're going to be joined by Monsi Roman, and she's going to be showing us how recycling is done on the International Space Station. So Monsi, what is ECLSS?
The Environmental Control and Life Support System is basically a set of equipment that will take care of anything that will keep the astronaut happy and healthy and breathing air that is clean. So it's composed of, for example, the life support system for air will take the CO2 from the crew, from the humans, and then take it away from the air. And then we have systems that will take that CO2 and convert it into water. So that in the air side, it's mainly cleaning the air, making sure the air doesn't have CO2 as a contaminant or other contaminants, because humans also have contaminants like ammonia and methane, other things that come from our bodies. So basically it's keeping the crew healthy in the air side. The water side, the life support systems recycle the water that the crew uses. So what we're trying to do is making sure that the water that they use is free of microbes, free of chemicals. At the same time, the water has also some chemicals in there that make the water more palatable. So they're not just drinking distilled water, for example, which is what we're doing. So it's a whole system that takes the water from the time it's dirty. So we recycle urine, for example. So we store the urine, we recycle the urine, and then comes back to the crew for drinking. So those are the two basic main systems of the life support systems.
What is the importance of recycling on the space station?
Recycling in the station is very important for many reasons. The first one, of course, is money. The more water we can recycle in station, the less water we have to bring to the crew every time. And approximately, if you think about a pound of water, it's about $19,000 to launch. That's including all the price of having your rocket and everything. You can imagine that after a while, having a processor that will recycle the water that you have in there makes sense. And that's where we are right now. We can save a lot of money by just not having to launch as much water anymore. A person will need, to stay healthy, will need about from 1 to 2 gallons of water a day. So if you multiply that by 6 people and you multiply that by all the days they're up there, that's a lot of water and very heavy water. So it makes sense because it saves money. It makes sense also because on top of that, you generate less trash. So if you recycle in station, things like your food containers and other things, now you make a lot less trash. Your containers are smaller, you are more conscious of everything around you, clothes, all those things. You have to be a little bit more thoughtful about what you're doing up there, because the more trash you generate, you're inside a can with your trash. So, and there's only so many times during the month that you can take that trash outside of your house. So the recycling in itself helps the crew stay healthy, the crew stay comfortable, makes sense because it saves money, and also helps us on Earth learning how to live a little bit more frugal, with a little bit less, and still be very comfortable and healthy.
Where does the water come from?
Well, in space station, we do not have showers and we do not have sinks to wash your hands. So there's two main water streams that we recycle. One is the condensate, and condensate is basically water that comes from your body, so your sweat, comes from respiration. So when you talk, when you sneeze, when you open your mouth, there's also humidity that comes out of your body. So that water also goes into the air and becomes a condensate for us, plus anything in the cabin. So the astronauts are heating food, some steam is going to come in the cabin, so we're going to take that steam also. So we're going to take as much water as we can out of everywhere in the cabin. And then the bigger one is the urine. So all the urine the astronauts donate to the system gets to go through a system that basically distills the urine.
How do you recycle drinking water from Earth?
On Earth, we recycle the water you drink every day. It's just that you don't think about it, because when you go to the restroom and you flush your toilet, the water goes to the river or the lake, and when you open your faucet, the water comes from that same lake where it went to. So there's a process in between, your toilet and your faucet, and that is actually recycling of water. So we have been drinking recycled water. Nature does a lot of that work for us too. So we have been drinking recycled water for forever, since we were born.
How do you remove carbon dioxide from the space station?
When we breathe out, carbon dioxide comes out, and we have a really neat system called a carbon dioxide removal assembly. We call it CDRA for short, and it takes the carbon dioxide out of the air. We bake it and expose that carbon dioxide to space, and we send the carbon dioxide overboard. The neat thing about the CDRA is that it's recyclable, so it's not a consumable. It can take a lot of carbon dioxide, send it out to space, and do it over and over again without us having to bring up new supplies.
What is the term Mother Nature recycles?
Well, on Earth, we don't think about it because Mother Nature does that for us, and she's wonderful. We have trees, which we tend to think is the major source of removal of CO2 and production of oxygen, but actually tiny organisms in the ocean are the ones of the bigger producers of oxygen for us in the world. So nature does that for us. It's a given for us. So the more contaminants we put on the air, and the less trees we have, and the less clean oceans and healthy oceans we have, the less clean air we have back to us. So we do need to take care of that.
What is sweat collection?
In our testing facility, the sweat is collecting pretty much the same way it's collected in station. We use what we call condensing heat exchangers, which are, in very simple terms, it's a metal piece of equipment that is maintained at colder temperature than the air. So when the air passes through, the humidity will condense. Very similar, like if you have a cold water glass and you put it on the counter and leave it there, when you come back, there's droplets of water outside of your glass. That's the very same principle that we use in the condensing heat exchanger.
How do you test the water processor assembly?
The process of testing the water processor on the ground was an incredible experience for us. We were the first ones. The United States was the first one to actually design, build, and test a water processor that will take urine and condensate to produce clean water for drinking. That had not been done in space before. So we had to use a lot of volunteers. So a lot of us were volunteers that donated. We had over 100 volunteers that will come and donate our sweat and our urine for testing our equipment. And so basically it was a trial and error way of doing things. There was a lot of modeling, so that the engineers will come and think how they thought the best way of doing this will be. Then they put it on drawings, and people will build the units, and then we'll basically tested it, for months and months and months until we were happy with the results. And then we did it all over again. So it took about 15 years of testing and to produce the water, constant water that we wanted, and the quality of water that we wanted and we needed.
And what is the taste testing?
Very interesting process too, the testing of the product water. Because in the beginning we were not allowed to drink that water. That water was produced, and because we had no idea, we knew the quality, we tested for chemicals and microbial components, but we were not sure, what kind of effect that kind of water will have on people. We were bound by protocols that would not allow us to drink the water on the ground until a lot of more testing was done. So in the beginning, we're only allowed to taste the water. So it was like a Coke and Pepsi kind of test, blind testing. We had, water from your faucet and water from the water fountain and our water. And we brought lots and lots of people to come and tell us if they could taste the difference and what it tasted like to them. And they were only allowed, it's like a wine testing. You were allowed to swirl it around your mouth and then you had to spit it out. So that was the beginning of the process of approving this water for human consumption. And then it had to go through a lengthy process of doctors making sure and coming back and telling us, okay, it's good, people actually can drink this water. So it was a really cool process.
I hope you've enjoyed the podcast, and I'll see you in the next one.